In this video, we will be demonstrating the flight demonstration wind tunnel, the AF41V, specifically for courses related to aircraft engineering. This is a hands-on simulator that consists of a model aircraft suspended in an open circuit wind tunnel that allows students to experience a variety of hands-on flight simulations to investigate the behaviour of fixed-wing aircraft and wing performance using fly-by-wire control. Previous versions of this apparatus are installed in aerospace engineering labs across the world, including the likes of East Africa School of Aviation in Kenya. There are common misunderstandings about how an aeroplane flies. These are due to the errors in defining how a wing shape or aerofoil produces lift. A classical explanation is that a good aerofoil shape should be one designed so that air travels at a higher velocity over the top surface than over the bottom surface, so that the difference in speed produces the lift. In truth, almost any shape can actually produce lift, providing that it is propelled fast enough and at a suitable angle. By using the flight demonstration wind tunnel, you can look at how an aerofoil produces lift and provides a basic understanding of key requirements of aircraft flight. Specifically, you can learn about longitudinal stability and control of the aircraft to demonstrate behaviour during takeoff, level flight and landing. You can determine the effect of speed on altitude for level flight and stall, measure the lift curve for the wing up to and beyond stall. The latest version of this product has integrated versatile data acquisition, that is VDAS on board, that allows students to trace data of altitude and attitude that can be charted, analysed and exported into Microsoft Excel for a much more detailed scientific study of behaviour of the model aircraft, including phugoid oscillation, reducing the need for separate bulky recording equipment previously required to capture the oscillation period. The fly-by-wire control offers improved control over the model aircraft. The electronics display on the front shows the airspeed, attitude, pressure and lift. Also means that this experiment can be used effectively to perform accurate analysis standalone without using VDAS if preferred. There are many other features that I'm going to go on to talk about shortly as we take a closer look at the different parts of the apparatus. The main area is an open circuit wind tunnel, and within the working section is a model aircraft suspended. This is supported by linkages that allow it to move vertically and to pitch about the quarter chord point independently. Air enters the working section of the wind tunnel through a flow straightener, which is important for settling the air, and the throttle controls the airspeed in the tunnel by regulating the speed of the axial fan at the other end that sucks the air through the working section where the aircraft model is suspended. The model aircraft is a scale model of a conventional aircraft with a two-blade propeller at the front and a fixed main wing with no control surfaces and a pivoted tailplane. The main wing has a NACA 2412 aerofoil section and is attached at an angle of 2.5 degrees. The all-flying tailplane has a NACA 0012 aerofoil section. This design is commonly used on subsonic aircraft as it produces greater control forces at all speeds and is low cost because it has a simple structure. Here is a locking control that allows you to lock the angle of the tailplane to any setting. The control column is connected to the tailplane of the model aircraft. As we push it forward or pull it back, it changes the angle of the whole tailplane. These small tufts that cover the port wing of the model aircraft show the direction and quality of airflow over the wing surface, making it easier to see separation and stalling. An optional extra is a smoke generator and probe, the AF41. This improves the visualization of airflow. We use this same device to visualize airflow over a car when working with a Top Gear TV production team to look at the airstreams to illustrate the concept of ground effect used on sports cars in the 1970s and 1980s. Back to the apparatus. There is an adjustable weight on the aircraft model to allow you to set the centre of gravity to different positions, from fore to aft of the quarter chord point. These scales show the exact position. As you can see, the working section is brightly illuminated. At the front here is a large transparent window. Onto the control panel and displays which show the air velocity within the working section, attitude, altitude, tailplane angle and lift of the aircraft. Now for the flight simulation. You fly the aircraft manually using a control column and throttle positioned right in front of the window and arranged in a format that you would typically see in a light aircraft. Once you've got to grips with the basic controls, you can carry out the experiments in the user guide that take you step by step through the practical study of the following elements. For more information on the flight demonstration wind tunnel or any other wind tunnels within the aerodynamics range from TecQuipment, click on the links below. Follow TecQuipment on YouTube to keep updated with all the latest videos and live events. Thanks for watching.